grandfather. All right, okay, uncle. I don't know. All right, an airplane is traveling east at 600 miles an hour. Another's traveling north at 750 miles an hour. If they left the airport at the same time, how fast is the rate of their distance apart increasing after 2 hours? In this type of a problem, I would say that this is probably the second most common problem I've seen on the AP exam. I've not yet done an AP exam where I haven't seen a related rates problem. The ones that you guys did yesterday are very common. This is another one. I'm going to draw the picture. I have a plane headed north and a plane headed east. So I have an east distance, I have a north distance, and then I have a distance for how far they are apart from each other. Can you tell me an equation that relates these variables together? Very good. I'm going to choose to use e squared plus n squared is equal to d squared. Is that okay with you, Hannah? Okay. So now we need to decipher our knowns and our unknowns. What do you know and what don't you know? What are you trying to find? And the class goes silent. E prime, thank you, is very good. So that would make n prime equal to 750. And what are we searching for? D prime. So let us take the derivative with respect to time. What is the derivative of e squared? Plus 2n prime equals 2d v prime. Wow, there's 6 variables in there that I need to come up with. I am looking for d prime, and I know e prime and n prime, but what are the 3 things that I e, n, and d, right? We still need those 3, don't we? How can we figure out the easterly distance thus far? Okay, thank you. The genius speaks up, and he says that because the plane is traveling 600 miles an hour, has been traveling for exactly 2 hours, we'd have east being 1200. Does everybody agree with Sam's assessment there? So therefore, the northerly distance would be 1500. How could we find their distance apart right now? The Pythagorean theorem. So if I use the Pythagorean theorem, which you guys have your calculator results, you can go ahead and do it as well. We will have the square root of 1200 squared plus 1500 squared, and I get 1900.94. 1920.94. All right. Now I've taken care of that little hiccup. I should be able to do the rest of the problem, huh? Go away. Scrolls. Okay. There we go. All right. So we have 2 times e is 1200 times e prime 600 plus 2 times 1500 times 750 is equal to 2 times 1920.94 times d prime. And I'll be solving for d prime. How about I get rid of you, exit you, and I'll keep you. 2 times 1200, 600, plus 2 times 1500, plus, whoop, times 750. I'll divide by 2, and I'll divide by 1920.94 and 960.47. on the AP exam, they will ask you to either round down to in your thousands place or round to the nearest thousand. So in this situation would be 0.467. And what is our label? Miles per hour. So we're okay with that? So in this case, your 10,000ths place is a 2. So this could be 467, right? And so whether you were to round down or whether you were to round to the nearest, it would still be 0.467. Suppose it was 960.4678. I have to verify this, but what I was told at the AP Institute this summer is that they will accept then either 960.468 or they'll accept 960.467. So you either round down in the thousandth place or you round to the nearest thousand. Either way, they'll accept it. That's what I was told. So basically, you could just cut off whatever numbers after that and just write it down. That's what I'm saying. Okay. All right, we'll move along. Don't do that. Okay. Our next problem. Yes, 5. A ladder is sliding down a building. The ladder is 12 feet tall. And it's a building, so there's some grass outside. There we go. And there's a window and a door. Very good. And a chimney. Because it's cold outside. You need a fire. And the fire got inside. Oh no, there's flames. Okay. Gotta find a way to make it fun, right? Okay. So it says the base of the ladder is moving at a rate of 1 foot per second away from the wall or the building and at the wall of the building. And how fast is the top of the ladder falling when the base of the ladder is moving or is 10 feet from the base? Good boy. Thoughts? Does the 12 ever change? No. Let's get to this point because it's a point of confusion that people have. Hannah just said, can we plug in 10 for x? Does x change? So therefore, you cannot plug it in right now. Does the 12 change? So therefore, you can plug it in right now. You have to consider what changes and what does not. So I will write an equation, x squared plus y squared is equal to 144. What do you currently know? What is 1? 1 is x prime. What else do we know? X is 10. What are we trying to find? Right. So we're going to take the derivative with respect to time of our function, or not our function, but our equation. And what do we get? Plus equal to 0. Good. Let's solve. 2 times 10 times 1 plus 2 times y prime is equal to 0. Uh-oh. What's going on? We don't know why. Can we find why? How? Plug it in. Yep, you know that x is 10, so 10 squared plus y squared is equal to 144. Subtract 100, you get y squared is 44. The square root of 44 is going to be what? 2 roots of 11? So y is equal to 2 roots of 11. So if I write this out, I've got 20 plus 2 times 2 roots of 11 is 4 roots of 11 times y prime is equal to 0. Or 4 roots of 11 y prime is equal to negative 20. Divide by 4 roots of 11. Y prime is equal to, what's negative 20 over 4? Negative 5, so negative 5 over the root of 11. Multiply top and bottom by the root of 11. Now I get y prime is equal to negative 5 roots of 11 over 11. And what is my measurement in feet per second? Can somebody tell me why my derivative is negative? Falling down. Very good. So this accounts for the fact that it's moving down. What do you think? Too easy. All right. Thank you. Let's try something that is more challenging, seeing how UI is getting bored. Oh, we're going to skip 6 because it's a bogus problem. I wrote a bad one. Figured that out last hour. Thought I had this. We'll come back to it tomorrow, but you got space. You got other space to write it. So sorry. We're going to do 6 tomorrow to revise it. Sorry. You crossed it out. We got space to write it elsewhere. So Boyle's law states that if the temperature of a gas remains constant, then the pressure P and the volume V of the gas satisfy the equation PV is equal to C, where C is a constant. Volume is decreasing at a rate of 10 cubic inches per second. How fast is the pressure increasing when the pressure is 100 pounds per inches squared and the volume is 20 inches cubed? Do you know what's going on? Do you understand the principle of Boyle's law? Okay, let me demonstrate. We continue to think of them and hope that they continue to get better. So in terms of modeling the problem, we talked about it, and we'll go on from there. So we have a formula. The formula is PV is equal to C. Somebody tell me my knowns and my unknowns in this problem. Yeah, V prime is equal to negative 10. Notice that it is decreasing. So the volume is decreasing, so therefore you write a negative number. Okay, what else do we know? What? Say it again. Thank you. P is equal to 100 and V is equal to 20. What are we trying to find? P prime. So I'm going to take the derivative with respect to time. And as I do that, what's the derivative? What do I have to use to find that derivative? Product rule. So we use the product rule. What's the derivative of P? 1P prime times V plus derivative of V prime times P is equal to, what's the derivative of a constant? 0. So a lot of times people want to know exactly what that constant is. In this case, it happens to be 20 times 100, which is 2,000. But we don't need to know that because the derivative of 2,000 is 0, just like the derivative of any constant is 0. So let's plug these pieces in. We don't know P prime, but we do know V, which is 20 plus V prime is negative 10 times 100 is equal to 0. So 20P prime is equal to 1,000. When I multiply negative 10 by 100 and I add it over the other side, I get 1,000. We divide by 20, and P prime is equal to what? 50. Now, I'll admit, although I feel like I'm a fairly intelligent individual, I don't remember how to put a label for pressure. But if I look back in the problem, it looks like pressure is pounds per inches squared. So I'm going to write pounds per inches squared. But this is a rate with respect to time. So therefore, we need to incorporate time. And what is our time measurement in? Seconds. So you could put this all over seconds over 1, or simply just multiply by the reciprocal. And seconds and inches squared will both be in the denominator is how that will work out. So that's a real label, pounds per inches squared seconds. Kind of complicated, but that's where we're at. We got 3 problems done even before lunch. We come back and all we want to do is we want to work through problem number 10. And then tomorrow there will be 3 or 4 other problems that we'll work through, and we'll be done with our related rates section, and you guys will kind of be on your own. So um, you'll so today we can pick up with these. You'll look at 8, 9, 10, 11, 12. So basically 1 through 12 you should complete, and then 16 and 18 would be good problems to look at. Tomorrow I'll add about 2 to 3 more, and that'll be it. But you're going to see that there's some level 3 and level 4 problems. We're going to do about half the level 3 problems, and the level 4 not required. So, but if you're getting bored with the content, you might want to look at them. Could be a good time.